The first thing we need to do for this Machinedrum trick is to set up a MIDI Loopback cable. I've got this handsome yellow Rat Shack cable that I'm going to be using. Just plug the MIDI output right back into the input. Okay, that's better. Next, I'm going to set up a MIDI machine. I'm going to put it on track 16, and I'm going to use the MIDI machine for MIDI channel 9, because I like to be difficult. And we're going to turn the default MIDI note of the machine all the way down, for a couple different reasons that we'll touch on again shortly. Now we need to go into the global menu and edit the MIDI settings. For the least headaches when implementing this technique, we don't want to send or receive any control messages. Using MIDI Loopback and CC messages is possible, but we will keep things simple. I also need to set my bass channel to 9, since I'm using MIDI machine 9. So now we need to go into the map editor and disable all the default MIDI mappings for this global slot. As you can see, using the scroll wheel to go all the way down the list of MIDI notes takes a moment. So this is the first reason I set the default note of the MIDI machine to the lowest note. The map editor allows you to use an external controller to map notes instead of having to use the scroll wheel. So now all we have to do is trigger the MIDI machine to get to the lowest value in the list, making things a bit less obnoxious. Also make sure to on-map any pattern switch MIDI mappings. Now it's time to enable a MIDI mapping for an instrument. We'll map it to the lowest note. Now to select an instrument. We can use any machine we like, but I've discovered some machines behave a bit better and exhibit less obvious flamming and glitching when you're interested in triggering them both with MIDI and their track triggs. Now we'll get some triggs down on the MIDI machine track. Okay, everything's working so far. Now we need a CTR8P machine that will allow us to control the MIDI machine's default note parameter. Okay, so track 16 and note. Now I'm going to use the LFO on the MIDI machine track to control the MIDI note parameter mapped on the Control 8P machine on track 15. We'll change the LFO shape to random, set the LFO to hold behavior, and turn up the speed so that every trigger on the MIDI track generates a new random value. We'll go to the Control 8P machine and make sure that the parameter controlling our MIDI note is set to the lowest value. Now watch and listen carefully as I turn up the LFO depth. As you can see, a depth of 1 does not appear to produce any non-zero MIDI notes, and a depth of 2 also does not produce any silences. It's only when we get to an LFO depth of 3 that we begin to hear silences introduced. As soon as we generate a MIDI note that is not the very lowest MIDI note, the instrument will not be triggered for that step. Let's take a closer look at what's happening with the MIDI machine and Control 8P machine. If you look carefully, you'll see that the value of the Control 8P machine is flipping between 0 and 1, but seems to be more often at 0. This is why I chose to use a MIDI note at the extreme of the range. There's a quirk with the bipolar nature of the LFOs that skews the output values slightly. By abusing this quirk, I am able to use this technique to produce probabilities greater than 50%, and I only need to use one instrument track to do it. Since we are generating silences with an LFO depth of 3, I'm assuming we are only producing silent triggs 1/3 of the time, but I'd have to do some analysis on the generated audio to be completely sure of that. As you may have noticed, as I move the LFO depth higher, we begin to get closer and closer to 50% probability of silencing a trig. Presumably, it is still a slightly lower percentage than 50%, even when the LFO depth is at maximum, due to the depth quirk that happens in this use case. If we want to obtain high percentages of trig silencing, that is easily done by adjusting the default note of the MIDI machine and the depth of the note transposition LFO. We could also map multiple instruments to different parts of the MIDI range to trigger different sounds, and we can also use the ability of the MIDI machine to generate chords to alter the various probabilities and trigger more than one instrument at a time with a single MIDI machine. In order to combine triggers that do not have probability with those that do, the easiest way is to simply place note triggers on the instrument track itself. To eliminate the flamming and glitching that happens in this usage scenario due to some MIDI feedback, local control needs to be off. I unfortunately missed this step when filming this particular footage. P-locking the triggs on the MIDI track is also a way to control the probability across the course of a pattern. Using prepared global slots, we can enable and disable MIDI mappings for particular instruments. Unfortunately, parameter locks are disabled when a track is being triggered externally, but this offers interesting performance possibilities using carefully prepared global slots, particularly when using this technique to trigger and control multiple sounds. Of course, we don't need to use this technique strictly for chance operations. By using regular LFO shapes, we can produce regular patterns. The shape mixing possibilities of the LFOs increase the possibilities with a single LFO, and also make it easy to introduce randomness to a regular pattern. The possibilities for pattern generation increase even further when introducing additional LFOs. Here's the first test kit and pattern I built, which triggers two different sounds using one MIDI machine. By changing global slots, I can enable track parameter locks while disabling the random triggers. And although I don't show it in this demo, it's important to realize that this can be done per instrument, and by using multiple global slots, you can quickly change things up on the fly. Dynamically muting the MIDI machine track is also quite fun. Now I'm going to bring in more patterned behavior by messing with the LFO shapes and shape mix. In this example where these sine wave machines are triggered by a MIDI machine, I'm currently using LFOs to produce a complex but regular pattern. By using an extreme of the MIDI note range, I am able to use global slots to dynamically map whatever sound I want to occur most frequently. When using probability, it is also easy to set one particular instrument up as a pedal tone that will occur approximately 50% of the time, while the other 50% of the time it will either silence the trigger or trigger a different instrument. You can hear a bit of that glitchy flamming because I have local control on in this example. With the MIDI feedback and the LFO modulation from the Control 8P machine, it's a little difficult to adjust the MIDI note range on the fly, and it takes a little fiddling. Let's switch on a bit of randomness. And don't forget, the MIDI machine can trigger more than one MIDI note at a time, which makes things a bit more flexible, although the complexity increases quite a bit, especially if you begin mapping more LFOs to this MIDI machine using the Control 8P machine. I'm going to switch this to more probability-based than pattern-based. If I didn't have local control on, this hi-hat right here wouldn't work because it's only being triggered by its internal track triggs. This video only shows the very basics of this technique. There are a lot of different ideas available for exploration, and a lot of quirks to discover and exploit. So get to work!